Hello learners, welcome to today's lesson. This is Form 4 Mathematics under Calculus, a topic that deals with differentiation and integration. But before we look at the question, if you have just come across this channel for the first time, kindly subscribe, hit the notification bell below so that anytime we produce a video like this, you will automatically be notified. Going straight to the question, the gradient of a curve is given by the function y is equals to 3x squared minus 12x plus 10. Part A, determine the coordinates of the turning point of the curve. Then you show that the turning point is a minimum point or simply a minima. Then Roman C, the curve passes through the point A with the coordinates 3, 1, expressing your answer in the form y is equals to mx plus c. Find the equation of the Roman 1, the tangent to the curve at point A, 3 marks. Then Roman 2, the equation of the normal to the curve at point A, 3 marks. Let us look at the working to this question. Under the working, you have been given the function y is equals to 3x squared minus 12x plus 10. And you are supposed to calculate or to determine the coordinates of the turning point. One thing a student should know is that at the turning point of a curve, the gradient function of that particular curve is 0. Therefore, we are going to get the dy over dx, which is the gradient function of the given curve. And in this case, we are going to get the gradient function by differentiating the given function, which is, if you want to differentiate this function here, you differentiate each term independently. In this case, to differentiate 3x squared, we take the power of x, we multiply by the coefficient of x squared, which is 3. So 2 times 3 will give us 6. Then we go and less 1 from the power of x. We are going to have simply x power 1, which is 6x. Then minus, when you differentiate this function here, we assume x is raised to power 1. 1 times 12 will give us 12. Then we go and less 1 from the power of x. 1 minus 1 would be 0, and any number raised to 0 is 1. So this one is going to be simply 12. We don't differentiate the function that does not have x here because we are supposed to differentiate y in respect to x. In this case, we know at the turning point, we know the dy over dx will always be equal to 0. So you take the gradient function, which is 6x minus 12, you equate to 0. Then from here we can get the value of x. If you take minus 12 to the other side, we are going to remain with 6x is equals to positive 12. And if you want to get the value of x, you are going to divide by 6 on both sides, such that x 6 and 6 goes to remain with our x, and our x is going to be equal to 2. Since we are looking for the coordinates of the turning point, we have the x coordinate, so we need the y coordinate. To get the y coordinate in this case, we are going to take the value of x into the main function for y so that we can get the value of y. The function we have is equals to y is given by 3x squared minus 12x plus 10. So to get the value of y here, we are going to take 3 times the value of x, and the value of x is 2, but that x is squared, minus 12 times the value of x, and the value of x is 2, plus 10. So 2 squared will give us 4, 4 times 3 will give us 12, minus 12 times 2 will give us 24, plus of course 10. Then if we take 12 plus 10, that will give us 22. Then 22 minus 24, this will give us -2. Therefore, we can say that our turning point is going to be equal to the value of x is 2, or the x coordinate, then the y coordinate is -2 here. And that is the answer to part A of the question. Then, going to part B, show that the turning point, this is the turning point here. This is the turning point we have. We are supposed to show that the turning point is a minima or a minimum point. What we do for part B, if you want to identify the nature of the turning point, we are going to draw a table having 3 columns. That is a table having 3 columns. And this one is going to be the values of x, but we are going to take this x coordinate and put it at the center here. Then we take one step to the left, another step to the right. We are going to have 3. From there, we take our dy over dx. Then of course we are going to look at the diagram here. So our dy over dx is given by 6x minus 12. So when x is 1, the dy over dx is going to be equal to 6 times x, which is 1, which is 6. 6 minus 12 will give us -6. And then when x is equals to 2, then our dy over dx is going to be equal to 2 times 6, which is 12. 12 minus 12 will give us a 0. And when the value of x is 3, then our dy over dx is going to be 6 times 3, which is 18. 18 minus 12 will give us 6. You realize the gradient is going to negative through 0 to positive, showing that this point is a minimum point. Therefore, we can simply come and say our turning point here is going to be the turning point, which is 2, -2 is a minima, or simply a minimum point. And by so doing, you have done that particular question very well. Now, going to part C. Part C is reading, the curve passes through the point. The curve passes through the point A, which has coordinates 3, 1. Expressing your answer in the form y is equals to mx plus c. Find the equation of the tangent to the curve at this particular point here. Then the equation of the normal. So C Roman 1, we are supposed to find the equation of tangent. So to find the equation of the tangent here, we already know that we have our first point, which is 3, 1. We also take a general point, which is xy, but we don't have the gradient. So in this case, what we are going to do, we know our dy over dx is given as 6x. Already we have gotten it here, minus 12. Then we know at this point, we are only going to take the value of x and substitute here so that we can get the gradient function at this particular point. So at the point where x is equals to 3, our dy over dx, which stands for the gradient, is going to be equal to 6 times the value of x, which is 3, we minus 12. And if you take 6 times 3, you get 18 minus 12. The answer is 6. Now we can pick our point, which is 3, 1. another general point xy, and the gradient, which is 6, for us to be able to find the equation of that particular tangent. In this case, to get the gradient, we know we take the change in y coordinate, so it is y minus the value of y, which is 1, over x minus the value of x, which is 3, and this one is going to give us 6. So 6 can be rationalized as 6 divided by 1, so that we can cross multiply. And in this case, if you take 1 times y minus 1, you are going to have y minus 1, which is equivalent to, if you take 6 times x, you are going to get 6x, then 6 times negative 3, you get minus 18. And if you take negative 1 to the other side, y is going to be equal to 6x. Then this is minus 18 plus 1. We are going to have negative 17. And that is the equation of the tangent to that particular curve at point A. Then, Roman 2 of part C, we are supposed to get what we call the equation of the normal to the curve at this point A. So we should always know that anytime we talk about normal, normal means perpendicular. So equation of the normal. So normal means perpendicular, and we already said that for perpendicular lines, we know that if you take m1, you multiply by m2, it will always give you negative 1. At this particular point here, we know m1 is the gradient of the tangent, and the gradient of the tangent is 6. So if we take 6 times m2, it is going to give us negative 1. If you divide by 6 on both sides, we are going to have our m2 is going to be equal to negative 1 over 6. From here, we can pick the same point, which is our point A, which has coordinates 3, 1. So if we take 3, 1, and another general point, xy, plus the gradient negative 1 over 6, we are able to get the equation of the normal to that particular point. So how do we find the gradient again? We know we take the change in y coordinates, so that is y minus 1 divided by x minus the value of x, which is 3, and this must give us negative 1 out of 6. If you cross multiply here, we are going to have 6 times y, which gives us 6y. Then 6 times minus 1 will give us minus 6, which is equivalent to negative 1 times x will give us minus x, or minus 1x. Then minus 1 times minus 3 will give us positive 3. If we take minus 6 to the other side, we are going to remain with 6y is equals to negative x plus, this is 3. Negative 6 go to the other side. So if we add it to 3, we are going to have 9. And in this case, in form of y is equals to mx plus c, we are going to divide by 6 all through, so that this and this goes, and our y is going to be equal to, this is negative x over 6 plus 9 divided by 6. 3 is common in both, so 9 by 3 will give us 3. Divide by 6 by 3 will give us 2. And that is actually the equation of the normal to the curve at that particular point A. Otherwise, that is how that question is done. And in case you have any question that you may like us to clarify, kindly go to the comment section, send your questions, and we shall be glad to address them accordingly. Thank you and welcome to our channel.